So a quick introduction about me. I've been into technology last 18 years and with different blockchains last 7+ years, mostly on the tech part. Currently, I work with the Near Foundation based out of Switzerland, but I'm based in Amsterdam, and I work here with my Balkan colleagues with the Near Balkans team. And that's the team that I'm representing today and the Near Foundation. But I also like to talk on this topic as an open source guy, try to be as, as unbiased as I can be from a technology standpoint. So without much ado, let's get started. So these are the things we are going to cover today. Like I said, a quick introduction. I'll give a 30 to 40 seconds talk about the entire journey of blockchain, interoperability, how it started, the challenges, different initiatives, and then what are the current problems, statement, and challenges we see in the blockchain interoperability space, and what are the different approach to solving these challenges and problems. Also, a lot of different initiatives that cross-chain or interoperable blockchain solutions are trying to solve. How do they do it, and how do they do it differently from one another? And like I mentioned, the different future outlook, which direction it will go, we never know in Web3, but there are certain directions some of these big interoperable solutions are taking. We'll also see some of those. And then where can you get started? Which chain or which thinking or which mindset you should take if you really want to dive deeper into the interoperable or multi-chain or cross-chain ecosystem. So talking about interoperability first. So the whole idea of interoperability, whether it is blockchain or whether it's information system or whether it is non-blockchain, it is about transferring data or information from one system to the other, right? That's the whole premise of interoperability, whether it is blockchain or non-blockchain. In blockchain, it becomes even more complex because there are different layers to blockchain as compared to Web 2 or Web 1 of the past. Like there are assets, these tokens that we call it. Then there are data that every blockchain has to share with each other across chains, but also across Web 2 or off-chain solutions. Then there are also different smart contracts. There are different programming languages on which these contracts are written and different syntax, programming syntax. Then there's another layer of different APIs that these chains consume. And then there's a fourth layer of different validator systems, the proof of consensus, proof of work, and different protocol consensus mechanisms that are used in these chains. So all of these combined, if there is an utopian solution, you would be able to transfer all these assets, tokens, data, smart contract communication, as well as a common validator or infrastructure with a standard consensus that understands each of these chains with the other. So that would basically be a full-blown holistic ecosystem of a utopian interoperable blockchain. So that's something that I wanted to list down here. I'll also talk more about it later. But before we go to the next point, let me give you a quick background of the Web3 or the blockchain ecosystem, how it started, from 2009, Bitcoin. So it was a means of just transferring your assets, right? In this case, the tokens. There was no smart contract layer until Ethereum came in 2015. So then Ethereum actually provided the possibility that you can start doing on-chain computation, trying to write all these dumb contracts, as they call it, into a smart contract automated way. Try to write the logic and agreements between two parties in a smart contract. So that made the system more efficient in terms of putting all this information on chain, which is immutable and can be verified by any party wherever needed. Now, after the smart contract evolution, we saw hundreds of chains, L1 chains as we call it, started creating their own network. So then we had, again, fragmentation of these chains that couldn't talk to each other. So we already started seeing the challenges that Ethereum solved with smart contract and on-chain computation. There was a new challenge now presented to the world. How do we communicate between these two different chains? One chain writing their own logic, data structure, smart contract, consensus mechanism, while the other chain had a different model altogether. And this is the Ethereum ecosystem. But then there were a lot of non-Ethereum ecosystems as well. They had a different programming language, data structures, so on and so forth. So when, in order to solve this token problem, sharing from one chain to the other, there was a new evolution of something called as centralized exchanges. Now, centralized exchanges was a completely was a big anti-pattern to the whole decentralized ecosystem because it was centralized in nature while you're building a decentralized solution, right? So the governance, the power, all those things was a big challenge. Also the security and risk and attack. Now, in order to solve that problem, the industry moved a little further and created something called as decentralized exchanges. And decentralized exchanges today is a big spectrum. Some are like 20% decentralized, others are 40, some are 60, some are 80. So there's also a big spectrum and challenges in that area. A topic for a different day altogether. Now, in decentralized exchanges, the challenge is if you're listing token on your exchange, decentralized exchange or a centralized exchange, how do you move that native token to a different exchange? So then there was a concept of, there still is a concept of wrapping these native tokens from one exchange and sending it to the other exchange. And then imagine if you have to rewrap that token from the second exchange to the third to the fourth. It created a lot of expensive computing, as they call it in the programming language, with a lot of transactions, effort, and memory and computing power getting it into them, while also creating a lot of user experience side effects. In order to solve that, there was a new solution, which is creating bridges for these decentralized exchanges, which opened up another problem, which of security, hacks, so on and so forth, right? And then last few years, we have seen a lot of these chains. I can name a couple of them, starting with Van Chain, Polkadot, Wormhole from Cosmos, and Near. That's the company that I work with, creating their own idea or premise around how do we solve all these challenges that we see in the interoperable world in blockchain while still maintaining user experience, security, transfer of data, while also doing smart contract intercommunication between these chains. So that's also something that we'll see. And what are the different approaches and solutions that exist in the ecosystem today, and where should we go further from there? So that is the whole background, starting, like I said, starting from Bitcoin, Ethereum, centralized exchanges, decentralized exchanges, native token, bridges, and then going to the interoperable solutions. And like I said, you know, what is the whole idea of this interoperability? It's very similar to what we saw with a lot of other non-blockchain solutions, right? How do you communicate with another Web3 application or even a Web2 application with a set of data structures that is designed for your application? Are there standards that translate that? It's called the transformation of the data structure. And to be able to present it to a different application so that they understand what language it is written in, whether it's a smart contract, the data or the assets, and how do you exchange and collaborate to build something for the industry rather than building something for the chain. A lot of these networks build something for their own chain and growing their ecosystem instead of looking at a larger decentralized mindset on which the Bitcoin or the Ethereum ecosystem was actually built upon, right? Like, let's build it for the community and do it together. And that's why you see a lot of these inefficiencies, a lot of hacks, because things are being built too fast, not tested well, challenges communicating with other solutions. And as a user, I can tell you my example. I have at least accounts with 20 different centralized exchanges, blockchains, and another dozen wallets that I interact with every now and then in order to do any transaction. So ideally, there should be one standard solution, like what we had with banking in the day. Every bank had their own system, and then there was a Swift system that came to wrap all of these things around it. So that's the kind of evolution that we are seeing now with a lot of solutions that we'll talk or see later today. So that's the introduction and background. Some of the challenges, like I mentioned, right? So I have a blockchain, I have my own consensus mechanism. The other blockchain doesn't understand it or is not able to communicate with it properly because of the protocol I follow, which is not a global protocol. And there are no standards to sharing data or data exchange, also something we still see in the Web2 world, between these chains or networks. The other part is everybody has a different transaction scheme, a different gas fees mechanisms, the way it is written, and also the different protocols that they follow, whether it is following the finality, some focus on finality, some focus on transaction speed, some focus on congestion, throughput, among others. So that creates a lot of variation and fragmented ecosystem within the blockchain network today. And that's what we see, that actually adheres not only with scalability and innovation like we see here, it also creates a lot of risk and bad user experience, because you have to create 20 accounts in 20 different systems. So imagine like you're using Google account, you're using a Microsoft account, you're using some other account, and you're doing it across 20 different chains if you're like really active in the Web3 world. So it's a lot of remembering those passphrases, storing them securely. Sometimes you store it somewhere else, people hack it, try to take your funds. Then also challenge on the technical side with bridges not being built and tested, not battle tested. So then you have also hacks in that area. And these fragmented use cases also have different challenges. So I am building something for e-commerce industry, or there are 3 chains building something for the e-commerce industry, while half of the chain is focused on a different industry, while trying to solve at least the problem of the top 3 industry focused together as the decentralized ecosystem. They build things that are very specific to their use cases, which also creates another concept. There's a concept called as semantics, like understanding the language that you speak versus the language of the other chains, right? So you talk a language which is, and the keywords and the naming convention, which is so different in the e-commerce world as compared to the manufacturing world. So that is also creating a lot of fragmented, and the effort are being, so it is nice to work on 2 or 3 use cases and divide the party, but that should also be a collaboration at the end of the day, or during regular intervals where you come back together and see how can you bridge these challenges. And that's the one that I'm talking about. Also, there are also these duplication of efforts. What I mean with that is there are 20 chains trying to build the same solution over and over again, right? 20 different networks. So again, in that area, there could be a very decentralized or open source approach where you publish something on a big open source Web3 community, like a bug bounty program in the security world, or like building an operating system like in the Linux world, where there's a list of 20 things the industry is currently going through, and different networks could come and contribute to building and taking the industry forward instead of bringing them back and focusing on their own benefits. There are different approach. So there are, like I mentioned, since there are different protocols, there could be a standardized protocol that everybody follows, or there are data interchange mechanisms. So there is a concept called extract, transform, load, or extract, load, and transform. So the idea is you take data, change it to the way the other system can consume it and process it. So that's a very similar approach you could use in the blockchain world, because the because the foundation or the bottom line is same. It is built on like they say, it's built on the same technology that Web 2 and Web 1 was using, but a bit more complexity added to it. Now, this data exchange, so there should be different data exchanges where you can go publish your data, get your data back, like this open maps. Very similar competitor of Google, that anybody can go. There are different standards. You can follow those standards, and everybody talks the same language, right? That increases a lot of collaboration in the ecosystem. Now, there are certain examples, like I mentioned here. So there's interledger protocol, where you can share data between 2 ledgers or networks as well. There are atomic swaps you can do. Wormhole from the Cosmos ecosystem is a very interesting use case where you can exchange assets, you can exchange data, but you can also build a network that belongs to the Wormhole ecosystem and call yourself a guardian network. With the Near Foundation, at Near Foundation, we built something called as blockchain operating system. So this is very similar to what we saw with the Apples of the world and the Androids of the world, where there's an app store or an iOS store. You can build basically your solution and deploy them so that people could use it. A very open source, build, fork, consume, and rebuild model. I'll talk about it a bit later. But it also has a different layer of building your own gateway so that you can communicate across chains, while also choose where do you want to write your final settlement transaction to, whether it is Ethereum, Near, or some other solution, some other chain. So you can also choose which chain you want to write your solution to, depending upon which wallet you're using as a user. So you don't have to add a new wallet to your ecosystem, and which solution you're using, and what gas fees, what performance, what finality, and what scalability and security you choose. So it gives you a lot of options. This is still something that we launched 2 months ago. It's going through a lot of development. If you want to talk more about it, I'll be more than happy to discuss one-on-one after this talk. That's something that anybody from the open source can basically contribute to. And then the other approach, I'll also talk about it in the next slide, is there are these side chains. There are plasmas, and then there are also these shards. So we'll also talk about it about the different approach and also dive a little deeper into them. And there are, like, how do you connect these multiple chains, but also how do you connect the chains spinning out of the main chain, right? So they are called either shards, plasmas, side chains, parachains, and so on and so forth. So those are like either child chains or a mirror chain of the main chain running two different transactions together. So that's another approach. I'll talk about it and the differences in the next slide. But you can also, peg tokens on one chain and then use it on the other chain, so that you don't have to, what I spoke earlier with different decentralized exchanges, that the native token have to always be wrapped, pass through the rainbow bridge, creates a lot of user experience, but also security risks and so on and so forth. So you could basically peg your assets to one chain, and that pegged asset can be actually used on the other chain, like what we do currently with gold, to peg USD to also maintain or avoid volatility there. Some of the example here, like I mentioned earlier, is the Bitcoin Lightning Network, Ethereum's Plasma, Polkadot has parachains, Polygon has side chains, Near has shards. So these are the different approaches to interoperability. So these are the three things I think we should look at. Let's look at it one by one. So in a shard, it's like a shard is like a complete copy of all the transactions you can write on a chain. It's like an independent chain by itself. Basically, you're creating a mirror of all the things that a particular network has, writing transactions, finality, their own consensus, their own gas fees, and everything. Basically, you can run a shard as one network separately or independently of the main net, but you can still do a sync or a cross communication call with the main net whenever you want, or upgrades. So, and as you can imagine, you are taking the entire chain, creating a copy, a mirror of it, and writing everything on it with everything. That's why you have low throughput. Sometimes also takes a lot of time, and the gas fees can also be higher because you're writing everything real time instead of bundling them or rolling them up into one big on-chain transaction. The other option is Plasma, right? So Plasma basically is like a side chain, but they do not have their own finality and other solutions that are built into it. So it is like they call it is like the child of the parent chain. So a Plasma runs by itself, but the good part about Plasma is that if there are any defects on the Plasma, it can leave that part of the defect and move on. And it's like what we see with the GitHub, if you're aware, creating your own branch. And if the branch is a bit corrupted, then you can leave that branch and spin up a new branch and leave all the security and performance and other issues with the previous branch. And like I said, so you can create your Plasma around your own design, add more privacy to it, create extra layers to it, while also choose your Plasma to write to the transactions to the main chain based on your preference, performance, and gas fees that you have. Quick check on time. I have 2 minutes. So sidechain, also very interesting. So in sidechain, like I mentioned, right? So you could run the main chain, but also run side chains, which can choose to roll up transactions and write all the transactions to the main chain. And again, that is something that you can choose and write on your own. One of the good part is it is very loosely coupled with the layer 1 solution or the main network. So then you can also choose how to do the performance and other things around it. Some of the cross-chain protocols, we'll also see this in the next slide, so I'll skip this for the scarcity of time. Let's cover this part. So the benefits, like I said, so if we do this ecosystem collaboration, right, where all these Web3 networks come together to build a solution for the industry, right, or for the ecosystem, then we can really create a focused approach, somebody building an NFT-based solution, somebody building a gaming solution around blockchains, while somebody building an infrastructure solution or cross-asset solution. So there are a lot of these solutions that are being built, and now there is a huge discussion around AI, as we all know, right? So that is running into a completely different direction without taking the blockchain advancement that we have taken so far. A year later, 2 years later, we'll see the 5G revolution coming up. So we really have to look at it as like, how do we build things that are more scalable for the future? The community is ready and prepared with different categories, sectors, and so on and so forth. Let me take you to this slide. So these are the 4 projects I spoke about, right? Polkadot has, like I said, parachains. Very interesting. The transaction is spread over a network. One chain, again, supporting a dozen chains. Cosmos, one of the very interesting wormhole solutions. So Near also has an integration with Cosmos. And on Near, like I mentioned, I'll take a few seconds here. So Near has taken the blockchain interoperability in a different way, where it is broken down into different layers. So the first layer is front end. You can build front ends that can be consumed by any chain. Then the second layer is gateways, which is an API, the business logic of the app. You can deploy those business logic also on the blockchain operating system, can again be consumed by a decentralized front end, can be consumed by a centralized front end, while also be used by any chain under the hood. Then the third layer here is the multi-chain finality. So you can choose whether you want to write this transaction on Ethereum, on Near, on Aurora, that's the EVM shard of Near, or any other chain that we are going to integrate in future. So basically, as a user, you get the flexibility to choose the entry point, like which wallet and which front end you want to start with. And then you can also choose which APIs you want to consume, which smart contract. There's also inter-smart contract communication between Near and Aurora, which will also be extended to other chains. While also choosing, like I mentioned earlier, which blockchain do I write to, depending upon security, performance, scalability, gas fees, and so on and so forth. So these are some of the solutions and notable projects today. And that's my Telegram handle. If you want to reach out to me, that's my GitHub. You can see a lot of open source projects there as well, also including zero knowledge and some IoT projects with blockchain. And if you want to talk more about it, collaborate on the Near blockchain ecosystem, or with Aurora, our EVM shard, or any open source project, I'll be more than happy to talk to you. I also have the last slide from our Near Balkas team, so please scan this and participate in the NFT prize activity. Thank you so much.